Okay, so good day to our grade 8 Math Science High School students. For today, we will be continuing our topic on angles of elevation and depression. This is going to be the 8th lesson for the third quarter in geometry. So let's try to answer this question using both an angle of elevation and angle of depression in one problem. Standing at the top of a lighthouse 200 feet high, a lighthouse keeper sighted both an airplane and a ship. Both an airplane and then a ship. Okay, directly beneath the plane. Okay, so let's say that this is the airplane and airplane, and then directly beneath it would be a ship. Well, let's try to do that cleanly. Okay, so let's erase that and let's try to draw it nicely. Okay, so we're gonna be here somewhere. There we go. Okay, let's say that this is the lighthouse. Okay, so according to the problem, the angle of elevation of the plane is measured to be 25 degrees. Okay, so we have an angle of elevation of 25 degrees, and then the angle of depression of the ship is measured to be 32 degrees. Okay, so again, this is the angle of elevation, or the angle of rise, and the angle of depression. Okay, so for this problem, we need to find the distance of the boat from the foot of the lighthouse. So let's say that this is the foot of the lighthouse. So we need to find the distance between the foot and the sea. Let's say, for example, that this is like the lighthouse and it's like the sea. So let's say that's the foot of the lighthouse at 90 degrees. So this is the distance between the ship and the foot of the lighthouse. Okay, and we also need to find to the nearest 10 feet. We also need to find the height of the plane above water. So we're trying to solve also for this side measurement, the height of the plane above water, to the nearest 10 feet as well. Okay, so how are we going to solve this problem? Again, we have two angle measurements that are given to us for this problem, the angle of elevation and then the angle of depression. So to solve for the distance, if we're going to solve for the distance between the ship and the lighthouse, we need to find specifically the measurement of this line. Since this line is ideally parallel to this line and congruent to that line as well, and this is a right triangle ideally, and we know that this is 32 degrees, so we can solve for the measurement of this of this line, given that the height of the lighthouse is 200 feet. Okay, so to solve this problem, we can say that this forms a 90-degree angle. Okay, the light of the lighthouse to the 32-degree angle. And since that forms a right angle, we can say that we can find the measurement of this angle. That's going to be 90 minus 32, which is equal to 58 degrees. And since we're looking for the distance, if we try to ideally draw the lighthouse and the angle here, so this is 200 feet, this is 58 degrees, and this is the distance that we're looking for, and we have a right triangle. So if we have these givens, we're looking for the opposite side, and we're given an adjacent side. Therefore, we can use the tangent theta function, the tangent of trigonometric ratio, in order to solve for the value of theta. Since we already know the value of theta, we're given in this problem, the value of theta is 58 degrees. So this is going to be tangent of 58 is equal to the opposite side, which is d, all over the adjacent side, which is 200. So this gives us 200 of tangent 58 is equal to d. Okay, and if we're going to try to evaluate that on our calculator, so that's 200 times tangent of 58. Okay, so that should give us on our calculator. So that should give us 320.07. Or since it's trying to find it into the nearest foot, so it should be 320 feet. So therefore the distance of this, distance of the foot of the lighthouse to the ship here at this point is 320 feet. Now if the distance of the foot of the lighthouse to the distance of the ship is 320 feet, and it's similar to this one, so that means this is also 320 feet. 20 feet. It's also congruent. Therefore, we can solve for the height of this particular point here, the line of sight. Okay, the line of sight straight ahead horizontally, and the distance of the airplane. Okay. Okay, so for this problem, since we already know that this is 200 feet, okay, so now we can find the distance between the airplane and this line of sight horizontally. If we're going to try to draw the right triangle that we formed here, okay, so we have here a right triangle, and this is 25 degrees. And then we don't know the measurement of this side, but we do know the measurement of this side is 320, because this is parallel and congruent to the line of sight above. So therefore the measurement of this side, we have an opposite and over adjacent. So again, we're going to use tangent theta. Therefore tangent of 25 degrees is going to be equal to, because it's going to be equal to the opposite, which is missing, all over the adjacent, which is 320 feet. So this is going to give us 320 times tangent of 25, which is equal to the opposite side. And if you try to solve that using our calculator, or scientific calculator, so that should give us a distance of 149.22, or approximately 150 feet. Okay, there you go. So therefore, there's our opposite side. So therefore, the measurement of this side is 150, and the measurement this side is 200. Now, if the distance from this line of sight and the airplane is 150 feet, and the length or the height of the lighthouse is 200, if we add them, we get the approximate distance of the airplane to the ship, which is around 350 feet. There you go. So therefore, the distance, okay, we can write that down for letter A. So the distance between the ship and the lighthouse is 320 feet. And for letter B, the distance between the ship to the airplane, or the airplane from the ship is 350 feet. And that's how we solve this problem.